Hey guys, welcome back to my YouTube channel. In this video, we are going to solve short list with a lead code problem. The problem number is 148 and this will be an interesting problem. So the problem is saying that you have given the head of a linked list and you have to rearrange or sort the linked list in ascending order. So suppose you have a linked list given like 4 to 1 3 and you have to sort it in ascending order. So our linked list will become like 1 2 3 and 4. Same for the example 2. You have to sort it and return the head. It's simple problem statement, but the solution will be a kind of tricky and interesting. I will be using merge sort. So if you don't know about the merge sort, I would highly recommend you to watch the merge sort concept beforehand watching this video. Before if you Because if you haven't watched merge sort or didn't know the concept of merge sort, I think it would be hard for you to understand how I'm implementing the merge sort on the linked list. So do watch it, do the concept of the merge sort, then come back here. So without wasting any more time, let's jump to the dry run or the solution. What the merge sort is basically. So what merge sort is? First thing, merge sort is basically a divide and conquer approach where you divide your problem into subproblems and solve those subproblems and then combining your solutions to get your main answer, your final answer. But suppose you have a linked list, okay, and you have to sort it. You can sort it in the whole linked list in one go. But rather than solving the whole linked list in a one go, divide into two linked lists. Okay, and then sort it this sub linked list, this one linked list, and this linked list in themselves. Okay, after that, not after that, and then we can combine it. Okay, that's the whole concept. Merge divide the whole linked list into sub linked lists and sort them individually and then merge them. So if suppose this is our linked list, you divide into two linked lists. Again, this is a linked list. You can divide it further, so you divided it further. Again, this is a linked list with a two node, so you can divide it again. So you divide it again. And here you got two linked lists with one node in themselves. Means there's a one node in a linked list means it's already sorted. So if there's a one node, you can directly return -1 because it's already sorted. There's a one node in a linked list and is one node means there's nothing to compare with means it's already sorted. So you can return -1 from here and -5, sorry, 5 from here because they are already sorted. And then you can merge those and return it to your parent function. Then again from here you got a linked list like 1 5 and 3. There's a two linked list -1 5 3. You will merge them and send it back. From here it will send it back to the parent function, and same for the our right sub tree. So that was our basic intuition how we are building. So basically what we are doing is at every iteration we are finding the mid value. Okay, on the basis of mid value I am dividing our linked list in a two linked list. So every iteration what we are doing, we are finding the mid value, then calling the same function again to divide. No, sorry, I'm finding the mid value, then I'm dividing it to a two sub tree. Okay, two sub tree or you can say two sub linked list. And again we are calling, again we are passing this sub tree, this sub linked list to the same function, and the same function is what is doing is finding a mid value and is dividing it into further two linked lists on the basis of the mid value. So it's dividing into further. Then again is take the linked list and find the mid value, then again it's divided it into further. Until when? Until we got a null, means there is nothing in a linked list, or a single value in a linked list, single node in a linked list. If there is nothing or a single node in a linked list, means it's already sorted. So you can simply return it back. So from here you can return -1 and 5. Same for the this subtree, this some linked list. You can simply return 4 and 0. After that, it will merge it to make something. Let me see. It will make something 0 and 4. Sorry, 4. And then again it will pass it back to the main function. I mean parent function. From here you got something 1 -135, and from the right subtree you will get 04. After that it will merge those two linked lists and send it back to our parent function. So I hope you got what we are doing. First thing we are doing is finding the mid, then calling the same function. It is finding a mid value and dividing the sum two sub linked lists. Then again we are calling until we reaching a single node in a linked list. So okay, you got it. How our how we are dividing, but how we are merging, how we are merging two linked lists, because from here, uh, like I have drawn that this is single node, so it return -1, which is a linked list individually, and from here -5, which return a single node, which is 5. So at this moment, we got two linked lists, okay, one with a -5 and one with a 5. So you have to merge it. You got two nodes, two linked lists, and you have to merge those two linked lists, and they will be done in sorted order. So after merging it, you have send it back to your parent function. After merging it become -1 comma -1 5, and you send it back to the parent function. And from here it is a single node, so you send it back 3 to the parent. After that it send it back to -1 3 5 in a sorted order. So how's our merging is occurring, I mean working? So what you will do, you have two individual linked lists, and they will be sorted in self. So you can do, you can put a left pointer on the head of the first linked list and the right pointer on the head of the second linked list. Then you can compare those value. If my left value is less than my right value, you can simply say, you can create a dummy node temp. You can simply say temp, can you next point to my left value, because this one is smaller. After that you can simply move your next to your left next if they are smaller. So after again you're gonna compare 3 with our right node, I mean right pointer. If our right pointer is smaller, in this case it is smaller, so you will see next temp dot next, can you point temp dot next was somewhere here. So okay, my temp points to -1 at first, then again it will point to 0. So it look like this, and my temp will move to here. Let me correct it. So my temp will move to 0, and my right will move from 0 to 4. Then again we will compare, is my left value is smaller than my right value. In this case left value is smaller, so I will say temp is, can you next point to the 3 value? It will say yes. Then again you will move your left to your next. Then again you will compare your right with left. So if your left is smaller, you can simply say temp your next can point to the right node, because right node is smaller. Then again my right reaches to the null. When my right reaches to the null, what you can do, since there is nothing, since there is nothing on the right hand half, so you can simply say temp your next. Can you point it to the left next? Left. What I'm saying is when one of your linked list got exhausted, in this case, our right hand side linked list got exhausted. So do I need to further check whether this portion is smaller than or greater than on the right? No, because if this got exhausted means whatever there is a value is gonna be greater than this value. So you can simply say temp. Your next can point to the left. Got it? If suppose if our this left got exhausted, then I will simply say temp. Can you knock next point to our left? Right? Sorry, because I already get it. Because if my left got exhausted, means it have smaller value than the right. So you can simply put your next temp or next to your right. So I hope you understand. Let's try to code it up. I hope from there you can got the clear understanding what we are doing. So okay, so what we need to do? Let me create a function called. I will simply return from here. Return ms, and I'm passing the head. Suppose, not suppose. Let's create some function. Let's create function ms. It will take a list node type head, and what it will do if the base condition were if my head is null or my head my next of head is null, you can simply return head. It will be our base condition because like I said, if there's only one node you can simply return it. If there's a zero node or null node or one node, you can simply return it. So that's what I'm doing. After that, what we need to we have to find our mid of the value. So let's suppose our list node type mid node will be, let's create another function called middle, and let's pass the head. Okay, we will implement this middle function later, but it will give us the middle node. Then what we need to do, we have to create two sub linked lists. So I will create a list node left. It will be our left node, left linked list. It will be what? It will be our head because the left will be pointing to the head, and the same. Let's create the same for the right hand side. It will be our mid node. Sorry, not middle. Mid node next. Okay. So our left will be pointing to the this value, and my right will be pointing to the this value. After that, what we have to do, we have to destroy the link between this because we are getting two individually linked lists. Let's move it here. So we are creating two individual linked lists. So what we have to do, we have to destroy this link. That's how it will become two linked lists. You are getting my point? I think you are getting. So you have to destroy this link. That's how you are creating a two linked list, one with this and one with this. So you can simply say mid node, can your next become null? It will say yes, and our link will get destroyed with it. After that, what we need? We need to call the same function again on the left side. So I will call my left equals to ms and let's pass it the left. And the same for the right. Call the same function again, right. So after that, if we got the individual, we have to merge it. So let's return. You can simply call a function ms, let's call it 2, or you can say merge it, let's call it 2. You will pass two linked lists, one which is left and one which is right, and simply return this function because you have to return the merge sorted merging array after merging the two sorted array, not array linked list. Okay, so let's now build our middle function to find the mid value, mid node. List node middle, it will take a list node type head. What it will do, we are going to use our null pointer, you can say. So I will simply create list node, list node type what slow equals to head, and list node type fast, that will head next. Why I'm not using head? Because if our linked list size is of even length, suppose in example 1, if you put your slow and fast both at the head, in the first iteration slow will move here, fast will reaches two step ahead, so my fast reaches here, and again my slow reaches here, my fast reaches to null. So you can see that my slow reaches here, and on the basis of the middle you are dividing into two linked lists. So our first linked list will consist of 4 to 1, and our right linked list will consist only one node 3. Is it good? Because the left subtree is containing 3 node, and the right sub linked list is containing only one node. It's not dividing into two parts. So if my slow is pointing somewhere here, so my left will contain 4 and 2, my right will contain 1 and 3. So that would be good because it's divided into two subtree. I mean with the equal nodes. So that's why I'm pointing my fast here. So my fast here, my fast reaches to here, my slow will reach here too. And on the basis of the mid, you can simply return, I mean divide our linked list. So what we will need, we will write the same condition while fast and my next of fast. If they are not null, what I will say slow, can you move to your next? So my slow moves to the next, and same for the fast, can you move to your next of next? After that, you can simply return the slow because it will be pointing to the mid. So we build our middle function and we have to build our merging thing. So let's create the list node type ms2. Let's pass it the two linked lists. First will be our linked list. Let's call it the left simply. And next we will list node right. And what we need to do, I will create a list node type dummy, or you can yeah, dummy, list node dummy, list node type dummy equals to new list node. Let's make it a -1, and I will create my temp list node temp that will be pointing to my dummy. After that, what I need, I will start traversing in my both of my linked list. So while my left and my right, until one of them got exhausted, I will keep traversing in my linked list. So while left not equals to null, and my while right not equals to null. So what we have to do, we have to compare if my right left val If it is smaller than my right well, RIGHT, well, if my left well is smaller, then what I can say? I will say, temp, can your next point to the left and move your left. So temp will my left will move is one position, and if my right is smaller, if my right is smaller, then I will say temp, can your next point to the right, because right one is smaller, then move your right. Right equals to move is right. Sorry, next. And after that, you can simply say temp, can you move one step ahead? So temp will move one step ahead, and if here comes the twist. So I have said that if one of my linked list got exhausted, in this case my right linked list got exhausted, you can simply say temp your next can point to the left. So if my suppose left got exhausted means there's a right. If there's a right which is not equal to null, not equal to null, so you can say temp, can your next point to the right, because there's an element on the right. And if else, temp, can your next point to the left. After that you can simply return what you need to return, dummy, not dummy, next of dummy. Okay, because dummy is pointed to -1 and you have to return the head, means it will start somewhere from the left value or right value. So I think it should be working. If we haven't done something error, but we have done it. Anything else we need to change? Let's see. We have built the middle. Temp val, temp val. It's not val, it will be next 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 of temp. Why there are so many error, bro? I'm returning nothing. Why? Where? Line number 42. Line number 42. I can have to return the head. Let me check if this. Okay, so it is running, and I think it's got, yeah, it got submit up. So basically, what we did, we created our function in the we create return the function, so it went back to here. And in this function, what we are doing, if there's only one node in a linked list, you can simply return the node. Okay, if there's nothing, you can simply return it nothing. If there's one node, you will return one node. Okay, after that you are finding the middle value every time. The middle value is what is doing, it's finding the middle value and returning the middle node. After that, we are creating two sub linked lists. One is the left side on the left hand side, or you can say the left the sublink list or the right sublink list, and then you are breaking the link between them because you have to create two linked lists. If there's a link, that will be counted as a one, so that's why you are breaking it, the link between them, to create two linked lists. After that, you are calling the same function again with the left linked list, and it will again take the left linked list and it will divide it further, and it will keep going further until it reaches to the one, or the one node, or with null node. and when after it you can say after it got return a single node, then this function will call this will function again, keep calling the right function until it get the one single node. After that, this will return, it will return something. So you got the two linked lists from the left and right, and it will merge it. On the basis of this, it will compare the two value. If whoever the smaller, my temp next will point into that node, and after that we'll move your temp. At the same time, you're moving your left and right according to the value whichever is the smaller. So let's move to the Java. You can check the Java solution. I have already written it. So if I wait, okay, I think you can see the whole code. It will be the same, but you can pause it and try by yourself. So I hope with this you like my video. If you like, do like, subscribe, and if you have some comment, do comment below. I will provide the a problem link in the description box so you can check out from there.